Good day to all the panel. My name is Lim Shilong from FGKEE course BEA Year 4 student. And today I'll be presenting my final year project with the title of Control Design for a Live Follow Robot with IoT based monitoring system. First, for this project, it's about the control design for a self-built live follow robot with IoT monitoring feature. For starting, live following robot is an autonomous robot that can travel with pre-drawn line and is widely used in the industry to carry objects or items that not suitable for human to carry or help saving times and work. This project has a few objectives. First is to develop a live follow robot based on microcontroller with IoT-based monitoring system to monitor the robot activity and condition. Second is to design the PID controller that's suitable for the live follow robot. Thirdly is to analyze the performance of the robot with different type of controller and without the controller. For my problem statement, not all the line follower are implemented with advanced line controller. And this causes the robot sometimes to fail or travel smoothly when disturbance occur or there is the interrupt or items or obstacles that blocking the path. The user must spend a lot of time to monitor and check the robot condition whether the path is being blocked or not. First, this project is to implement with IoT-based monitoring system. With this, the user will allow to monitor the condition of the robot and the robot will allow to send the feedback task to the user through IoT monitoring system. Next, I'll be presenting the flowchart and also the methodology of this project. At the starting, the researcher gather the research of relevant article. Next, the researcher analyze the article gathered and define the informations and technologies that needed. Thirdly, hardware and software are being chosen that need to use to develop the system. After that, hardware and software testing for develop and research study is being done. After the testing, the researchers start to develop the line follow robot and collect the data. After this figure actually shows the block diagram of this system. Starting with IR sensor array, which is an array of IR sensors, and the component name is MakerLine from Cytron that will act as the sensor to detect the line draw and track the line. Second, the sensor will send the signal into Arduino Uno microcontroller to process with PID or other control. After the process, the controller will signal the motor driver, and here the motor driver being used is MX1508 and the component name is Maker driver, also by Cytron. And then the motor driver will send the signal to the DC motor on the left and right to perform the control and movement of the robot. At the same time, Arduino Uno will have communication with Node MCU with ESP8266 built-in, which sends the data or the condition of the robot into Node MCU to allow Node MCU update or upload into Blink applications that are online. At the same time, the control signals that sent by Blink applications also will be sending back into Node MCU and then received by Arduino Uno. After this, let us look about the PID diagram of this system. This figure shows the PID diagram of the line follower robot. At the starting, the set point is being set, and then the system will compare the error of the set point and then go through the PID algorithm, and then the PID algorithm will adjust with the base PWM signal which is the initial starting PWM signal of the robot, and then the signal will be sent to driver motor, and then the driver motor will send to the left motor and the right motor to produce the outcome of following line. At the same time, the sensor will detect the line position and send the error or the reading back to the robot, and then this process will be continued again. Next figure shows the data collection method that been applied. At first, when the sensor sends the line drawn, the sensor will send the data to the microcontroller board, and the microcontroller board will have serial communications with the computer, and the data will be sent and be collected with the help of Excel data streamer add-on. With the data streamer add-on, the data able to collect in 10 millisecond interval and can be slot and also analyzed and be drawn and present in the graph. Next, I'll be explaining the result and the analysis of this project. First, the table shown at here is actually the outcome when applying different method for the PID tuning. The first one is the systematic trial error tuning method, which the outcome is actually the PD controller because the eye control is hard to tune. The second one is Ziegler-Nichols method, which is the PID controller because the outcome can be easily gained by inputting or calculating the maximum oscillation. And here, the outcome of both tuning method are stable, but the systematic trial error tuning method have minimum steady state error that occur. For Ziegler-Nichols method, no steady state error occur because it's a PID controller instead of PD. For the settling time for both systems, settling time for systematic trial error is 0.89 seconds, and the calculation method I will be showing or already show in the report. For Ziegler-Nichols method, the settling time is lower, which is 0.78, and the calculations also will be shown in the report. For the tuning times that the user use for systematic trial error is high because the person need to adjust the value manually and need to consider the parameters when adjusting. For Ziegler-Nichols method, the tuning time is low because when you apply the Ziegler-Nichols method, the output of the system is actually nearly stable. So the researcher just need to adjust or tuning a little value or some value to achieve the desired outcome. For the limitation, the systematic trial error tuning method has limitation based on the persons or the researchers that tune the system. And here I mentioned it's hard to tune the integral terms because the integral terms will affect the speed up of the motor, and if the value is too high, sometimes will cause the oscillations happen and cause the system directly become unstable. For Ziegler-Nichols method, the value is gained fast directly from the table, thus the problem of tuning integral terms is not occur. But for Ziegler-Nichols method, the limitation is the ultimate gain or need to set the system into the stable oscillation. Some system with very sensitive when oscillate can be damaged. It's not suitable for using this method. Next, the tables that I show here is actually the outcome that I gain when tuning the PID value, and also how the PID value affect the rise time, overshoot, settling time, and steady state error. And the method of Ziegler-Nichols tuning is very direct tuning method, which allow the user to get the starting point of tuning very quick and able to perform tuning with direction. For the conclusion, all objective and working scope are successfully accomplished and achieved. First, the development of a line follower robot that based on microcontroller and IoT-based monitoring system is success with the implement of Blink application. Second, the design of PID controller that's suitable for line follower robot is success also. With the help of tuning method, Ziegler-Nichols method, the PID gain that used for the line follower robot has the perform steady with no steady state error performance. And also third, the analyze the performance of the system with different type of controller also been success with the data collection method of Excel data stream add-on. With all the performance of the controllers that we analyzed, and also the suitable controller are selected, which is PID. Next, for project feature, this project has the robot or line follower robot that travel with PID control system applied and can travel smoothly and adjustable the performance with the help of PID. Second, the user can control and monitor through the phone or web with the help of Blink application. And here I show the dashboard, web dashboard for Blink and also the phone dashboard for the Blink application. I will be showing more on the demonstrations of the project. For this project, novelty and inventiveness, the IoT monitoring of line follower robot is quite new to the market since most of the line follower robot are working autonomously without IoT monitoring feature. Next, for project potentials and commercialization, this project had the potential to improve with more advanced controller and currently is stable and monitorable. With more advanced controller applied, can be used to control the stop time or maybe the destinations travel and more. As life follower robot are the basic concept of automotive car, the control theory of this system actually can be improved and can move on into automotive carrier, even self-driving car. And this project can be commercialized due to the IoT monitoring feature with the stable performance. Now I'll be continue to the demonstration of this project. At the starting, when the start button on the phone blink is pressed, the robot will start moving and following the line. The robot will continue travel and stop if the obstacle is being detected. At the same time, the robot will send a signal to blink at the phone and show the path is blocked by the obstacle. If the obstacle is removed away, the robot will continue moving, and when the stop button is pressed, for example, when the person want to load the items on the robot will stop. And finally, the robot will inform and stop when it reach the station. That's all for my presentation and demonstration. Thank you very much.